So now we are going to see a new type of diode called as Varactor Diode. So this is the name should be very familiar to you. The Varactor Diode is a PN junction diode only, but only thing it is a reverse bias PN junction diode. The Varactor diode, the Varactor term Varactor means it is variable capacitor. So when you combine the terms variable capacitor, it becomes Varactor diode. Okay, the Varactor diode it is also called as varicap or a tuning or voltage variable capacitor diode. It's a junction diode with small impurity dose at the junction. So the doping level is going to be very small. So it is going to be conventional PN junction diode only. But only thing I am going to operate the PN junction diode in reverse bias condition. You know, in reverse bias condition, your P will be applied, the P side of your PN junction will be given a negative potential and N side will be given a positive potential. So electrons and holes will be attracted towards the battery and they'll be flowing away from the device, which will lead to increase in the depletion region width. The depletion region width is going to increase in reverse bias. And this depletion region can be viewed as a capacitance. You know, C is equal to epsilon A by D. Okay, epsilon is the permittivity, A is the area, and D is the width of the depletion region. So here you can see as the depletion region width is getting increased and increased, the capacitance value will become small. So wherever I want to use small value of capacitance, I can, where fabrication of capacitance is very difficult, there I can replace this capacitance by these capacitance by a PN junction diode operating in reverse bias. Here the reverse bias voltage will control the capacitance of my PN junction region. Okay, so that is what is shown in the diagram. The expanded PN junction region because of reverse bias PN junction. So larger the reverse bias voltage, the width also becomes wider. So the as you increase the voltage reverse bias applied across the diode more and more, the depletion region also width will become increasing and increasing. So when the width is going to increase, the capacitance is going to decrease because you know C is proportional to 1 by D. C is inversely proportional to D. Okay. So the symbol for the diode, Varactor diode is given like this. It is a normal diode plus you have a capacitor and this arrow mark indicates it's a variable capacitor. The capacitance can be varied or adjusted by varying the reverse bias voltage. Okay, it can be varied or adjusted by varying the reverse bias voltage. Okay, and you can see as the reverse bias voltage is increasing, the capacitance is decreasing. The depletion region width will increase. So overall, the capacitance will be decreasing from the maximum value at 0. So when there is no reverse bias applied, the capacitor value will be maximum. From then, as you increase the reverse bias in a negative way, the capacitance value starts decreasing. Though the depletion region, as you know, the depletion region is a region where you don't have any majority carrier. So it is just like an insulator preventing the N and P regions to join. So it can be viewed as a capacitor. So on both sides you have different charge carriers. In between you have a region which is going to act like an insulator. So it is just like giving a capacitive effect. Okay, so that is the region, or that is the reason why I am exploiting the property of reverse bias PN junction diode in the application of a capacitance. And also the reverse bias capacitance value is very small in the order of picofarad. So fabricating such capacitance in the order of picofarad is very difficult and not possible that easily. So in such case, I can substitute that capacitance value by a reverse bias PN junction diode. So it will exactly perform the same functions of the capacitor. Only thing is you have to have a reverse bias supply constantly kept around the diode for it to function as a Varactor diode. The Varactor diode symbol is shown. As you know, it is just like a diode. See, this is your conventional diode symbol. Additionally, you have a capacitor, and this arrow mark indicates it's a variable capacitor. The arrow mark indicates my capacitance can be varied as I can increase or decrease my reverse bias voltage. So capacitance, you know, it is proportional to 1 by W. W is the width of the depletion region. So capacitance varies inversely with reverse voltage. So as the reverse voltage applied to the junction keeps on increasing and increasing, the capacitance starts decreasing. So an increase in reverse bias will result in increase in depletion region width and decrease in capacitance CT. So width and voltage are related directly. whereas the voltage and capacitance are related inversely. V is larger voltage will produce smaller capacitance, whereas larger voltage will produce larger depletion layer width. Width and voltage are linearly related. Width and capacitance are inversely related. That's what is given in the last point. That you can make it out from the understanding itself. So at 0 volt, the depletion region is very, very small. So the capacitance value is approximately 100 picofarad, or I can say it is 0.6 nanofarad. So when the reverse bias is going to be 15 volts, the capacitance value is 30 picofarad. So you see how it is reducing from 600 to 30. So it has become 30 picofarad. The Varactor diodes are used in FM radio and TV receivers, automatic AFC circuit, automatic frequency control circuits, bridge circuits, and adjustable band pass filter. So the enormous applications wherever this capacitance is going to be used, those applications also fit in for Varactor diode. So in all the application like FM radio, TV receivers, this Varactor diode is going to be used. And with the improvement of type of materials used in construction, and in Varactor diodes find application in tuning LC circuits in microwave. So in high frequency operation also, these Varactor diodes are being used, some microwave frequency multipliers, and in very low noise microwave parametric amplifiers. So with construction and other technology becoming very simple, the fabrication of these Varactor diodes have been very easy, and so they have been used in high frequency microwave circuits for generating capacitive effect. So this is going to be the construction and working of Varactor